In this screencast, we're going to talk about carbohydrates. We often think of carbohydrates as things like bread or pasta, but there are a lot more to carbohydrates than just bread and pasta. Carbohydrates are made up of sugars and the polymers of sugars. So the monomers that we're talking about with carbohydrates are going to be different forms of sugar. Just a note, many sugar names end in OSE, so all of the ones that we talk about today will end in OSE, and you'll also see words ending in OSE on nutrition labels that are not these 6 types. So whenever you see OSE, it's almost always going to be a sugar. Carbohydrates are broken down in order for cells to use them as both short and long-term energy. Additionally, carbohydrates are broken down to then be rearranged and serve as the materials for other types of molecules, like amino acids that make up proteins and fatty acids that help make up lipids. When we look at carbohydrates, we can see there might just be one little monomer building block, one sugar. We can have 2 sugars, which is a disaccharide. This was a monosaccharide. We can have more complex polysaccharides that have more Legos, or we can have really, really big ones. This one is a record-breaking Lego tower. What's going to need to happen, though, no matter how we take them in, we're going to need to take them in their form that we ate them, break them down, and then we'll either use these parts as energy or we'll use these parts to build new things. So first, let's start with monosaccharides. Mono means one, saccharide means sugar, so this is just one sugar molecule. Our 3 monosaccharides are glucose, fructose, and galactose. Glucose is found in syrups and sweeteners. We can also think of it as in candy. It's found in many disaccharides. It's the building block for these disaccharides, or one of the building blocks, but it's the only simple sugar that's used by the brain. So whether we take glucose in its glucose form, or we break down other disaccharides or polysaccharides into glucose, it's the only way that our brain can get energy. Fructose is a type of sugar that's found in fruit, in honey, and root vegetables. So we don't usually think of fruit or honey or vegetables as high in carbohydrates, but sugar is a form of a carbohydrate. These are all simple sugars. Galactose is a monosaccharide that's found in milk and other dairy foods as a component of lactose. We're not going to talk about galactose now. We'll talk about it more when we talk about lactose. So then we have our disaccharides. Di means 2, so these are 2 sugars put together. The most prevalent disaccharide is sucrose. We're going to talk about sucrose, lactose, and maltose. Sucrose is when you have one glucose molecule that is bonded together with a fructose molecule. Sucrose is found in table sugar, molasses, maple syrup, candies, and cakes, which are usually because we put table sugar in there, chocolate, ice cream, and some fruits and honey. When we talk about chocolate, chocolate in its natural form does not have any sugar, but in order to take the cacao and make it into chocolate, we add sugar and sometimes milk. Lactose is formed by one glucose molecule and one galactose molecule. People can be intolerant to lactose, and that means they're unable to break it down. Lactose is found in milk, ice cream, cheese, sour cream, yogurt, so that is lactose. Our last disaccharide that we'll talk about is maltose. Maltose is found in spelt, which is often used as a gluten-free grain alternative, sweet potatoes, beer, and can be produced from corn as well. Next, we have polysaccharides. So we just talked about simple sugars. Now we're going to talk about complex carbohydrates. These are carbohydrates that are a few hundred to a few thousand monosaccharides all put together. Polysaccharides are used to store glucose because, again, glucose is what we actually use for energy. So the polysaccharides are either going to store energy, so we break them down and use them for energy, or we break them down and, as I said before, we use them to recreate other things for the cell. The first example of a polysaccharide we have are starches. Plants store sugars as starches so that they can use them for energy later. They're able to stockpile glucose in a way that animals are not, because plants are stationary while animals need to move around. The plant can then take this energy from the starch storage bank, break it down, and then use it as glucose monomers. When we eat a plant, we are also eating this starch energy stockpile that the plant planned to use for itself, but we use it instead. Sources of starches include potatoes, grains. Grains are wheat, corn, and rice. And so these are what you probably normally think of as your carbohydrates, even if it's something like wheat that's refined into flour and then becomes the building block for many of the foods that we think of as carbohydrates. Glycogen is the way that animals store energy from sugar. It's mainly stored in our liver and in our muscle cells. We break down the glycogen, and that's how we get our quick energy in the form of glucose. Glycogen can be stored, or sugar can be stored as glycogen for about a day until it's replenished, unless it is replenished. After that, it's going to turn into fat. So when we take in carbohydrates, we can either use them right now, we can store them for about a day as glycogen within our liver and our muscle cells, or after that, they're going to turn to fat. So these glycogen stores, or building up your glycogen stores, are the premise behind pasta parties. If you eat a bunch of carbohydrates the night before you have a big game or a long race, your body will store them as glycogen, and then you're able to use them up the next day. Now, that is the theory behind it. I think pasta parties are often more a social event at this point, but that also builds team camaraderie and is beneficial usually to the team's game. But that is the premise behind carbo loading or eating a bunch of pasta or other carbohydrate the night before an endurance activity. Lastly, we have cellulose. Cellulose is a structural material that's found in plants. Humans can't digest cellulose, so we pass it through our digestive system without being broken down. When you look at a nutrition label, cellulose will be listed as fiber or insoluble fiber. So even though we don't break down cellulose, it is helpful and healthy for our digestive tract. It also helps us feel full, so it can help curb appetite a little bit. And as we know, plants have lots of vitamins and minerals in them. And so even though we can't break down the cellulose, we still get the vitamins and minerals from the plant.